Okay, welcome back. Get comfy here with my neck pillow. Change curves to position continuity can be done with playing with the blend curve. You don't have to go through the guidelines of everything you have to do, and I'm going to throw in a little bonus here on inserting control points and knots and what that really means to a curve. So hopefully that'll start to clarify a little bit of this for the more intermediate rhino person trying to make awesome curves. Same thing, made my little vector out here. As before, just kind of copied my script as a grid, and then I went in and I made this curve and this curve, and you'll notice all I did to those two was just spread them apart a little bit as interpolated lines, and I decided to just play with those two square root. You can always pop this in, it's going to change the data and really funk it out and show discontinuity as we go. But let's just stay with what I had. I did not mean to do that. I meant to do that. And we'll slide through and we'll just reach and tool it so it gets a little smaller. So it's controllable as this curve and this curve. And we'll join those curves for the most part. First of all, I have to flip that curve. It's not behaving in the right order. And this is actually good practice for anybody into robotics because you really have to know the paths of where you're putting things. And so I took those wonderful curves right there and made this lovely W, I guess, for Wickerson. And I've got continuity. I can switch over from this is curvature continuity, this will be tangency continuity, and this will be position continuity. And so there's a little bit of funkiness that happens here. And what's nice is if we analyze that and put it over to, say, this 2, which is the most exciting to look at, and join our curves, we can analyze that as curvature graph, which will give us not only, and it's right in the middle right now, so I can't see much. Hang on, let me move this over. There's our little circle. I at least can show my graph. And you see the graph is pretty sweet looking as it moves through here and dips through this inner circle. If I move my continuity back to tangency, you can see that there's not much going on in between that curve all the way down and then straight across. There's a little dip of weird jig happening here, which I find pretty interesting just because of the nature of points and dividing them and then making sure they work or not. And you could always take it right down and clean it right up with 0. So it's just a point tangent, so you don't have to worry about point continuity. But if we stay to this one, I threw in an extra tool so we can analyze the curve, and we can analyze the circle, the vector at that point, and as I move through it, you'll see that circle is playing off its vector. I believe it's called the vector, curvature vector, and then you can also see the curvature curve, and you can see the point of where that's happening. So I've just re-parameterized my curve so I can take that all the way down. You see it does quite a bit of jumping and smooth and produces some really nice symmetric geometries. I've taken extrusion off of it so we could bake it and see what it looks like as well. What I did then was playing with that, was that I said, let's write that script again and go in here and play with the blend. Which is really nice. So right now it's set as bulge A and bulge B to 1 and 1, but you can start to get this really weird stuff happening, which is referred to as the bulge. If I start to move this off to this direction, you can see all the way back to point 0, so it just kind of makes a quick kink in the fabric. But if I bring it over here, I can fletch it right to the middle until I'm actually pushing it a little bit too far, past 1, which is not so good. So snapping at 1's ideal. And the other side, I can pull the bulge back this way. But if I take them both up above 1, and I can kind of do this little loop and get it kind of running through itself as it loops through, and then you can see the curve continuity. So if I brought that in and did the same point on this one, you have this other really nice decorative frame to kind of think of optically, and also be able to grab your circle and curvature circle through that. It does a big loop all the way around. It does this kind of wonderful action of moving. Now that would be a wonderful piece of geometry to drive geometry from, just from the geometry coming out of that curve. And you can actually access that curve, which is nice. We can take that curve, but can actually bake it in and bake those geometries, unlike the curvature graph, which kind of trails off like a visualization only. So I found that very exciting. And then off to the side, I did a little side study here, which is a little bigger. I'll just pull this over here. Playing around a little bit with what's going on here. Where did it go? Over here. Insert control points. Basically, I put in and I hard coded in these 4, which I don't like to do, but I internalized it so it's there. You have to be careful with the number of control points when you're dealing with the degrees. You have to be at least 1 less, so you can't go up to 4 or sort of fault out. But I could go down on my tangent C and change that. On my degree, so I could go to degree 2 curve and degree 1 curve. You see how that's kind of playing through. And then the weights are what really affect the knots, and the knots just is a number of count, which then you can make periodic or not, which I'm not going to, but you can play with the weights that are associated with each of those points. You don't want to put them at 0 because then they just default to snap off, but you can push them almost all the way down to 0. And you see there really is this push and pull of what's really driving this curve. You can really have a lot of finesse through a gene pool to generate from simple curves. So it gives you a sense of what is important in a NURBS curve. And it's not just control points. It is the knots associated with it, and certainly the weights of what's happening at those points. So very nice little exercise. We're going to go into something a little more philosophical in the end. We're going to talk about total matter and back into the phenomenon of man. We're going to enter also over here. As we get into this, we're going to move into total matter, and we're going to look at the system, the totem, and the quantum, which I talked about before, but I also wanted to go hard into chapter 6 of the second certification form dealing with surface continuity, which is a real extension of the curve continuity that we've done. So I hope you find this very exciting. I'm excited about it. I keep putting up these videos, and hopefully it'll make for a very interesting master script that somebody would like to pick through some interesting scripts, watch the videos, and have this as a source material for them to play with and think about. Because that's all it's about, is just trying to draw a kind of spiritual, philosophical, and art-based, mathematical bridge between all of those things, and using data visualization to do it. Because Rhino and Grasshopper are a great tool to, I think, really develop one's mind and think a little different about maybe what they've been doing. And as an artist, this seems very essential to me. Thanks very much for watching.